A-level maths, quickly recapping, expanding single brackets, simplifying algebraic expressions, and working with indices in this video lesson, okay? So, for this first part, okay, it says expand these expressions and simplify if possible. Part A, x cubed brackets 4x squared minus 7 brackets closed plus 2x to the power of 5. So we are going to expand the single bracket. So I'm going to do x cubed multiplied by 4x squared and x cubed multiplied by minus 7x. X cubed times 4x squared, that'll be 4x to the power of 5. Because when I multiply x cubed by x squared using our index laws, we are going to add the powers because the base is the same, the base x. Then we got x cubed times by minus 7 is minus 7 lots of x cubed, so minus 7x cubed. And then I'm going to tag on the plus 2x to the power of 5. Now I'm going to collect my like terms. So collect my x to the power of 5 terms together. So 4x to the power of 5 plus 2x to the power of 5 is 6x to the power of 5 minus 7x cubed. Okay, so the answer for that one is 6x to the power of 5. Sorry if it's a bit small, I apologise. Okay, 6x to the power of 5, not 3, minus 7x cubed. Okay. Again, sorry for actually squishing it a bit there, but I haven't got much space for each part, and I might not be able to write there every single answer. So if it gets deleted, I apologise, but you're able to obviously rewatch it back at any part or parts. Part B, minus 5x squared brackets 3 minus 8x minus 5x squared times 3 is minus 15x squared, so minus 15 lots of x squared, and minus 5x squared multiplied by minus 8x. Well, minus 5 times minus 8 makes positive or plus 40, because the two negatives that multiply together make a positive or a plus as a sign. I've got x squared times x makes x cubed. So we get 15x squared plus 40x cubed, or I can rewrite it as 40x cubed minus 15x squared. Okay, either way would suffice for the examiner. Okay, for that. Right, what about part C? We got x lots of 3x plus 4 brackets close, so x brackets 3x plus 4 minus 7 brackets 5x minus 2. So we do x times the 3x makes 3x squared. X times the plus 4 is plus 4x. Then I've got minus 7 times 5x makes minus 35x, lots of x, and minus 7 times minus 2 makes plus 14 or positive 14. I'm now going to collect my like terms. Okay, we got a 3x squared. 4x minus 35x, be careful, is minus 31x plus 14. If you're ever unsure here on doing subtraction here with negatives, if I've got plus 4 and I'm taking away 35, I can just do 35, take away 4, okay, and then stick a minus sign at the front. So 35 minus 4 is 31, put a minus at the front, we get minus 31. Okay, of course, you are welcome to use your calculators here in AS level maths, but this is just some good practice in case you're working with negative numbers on a larger scale. Okay, so that's how my brain works with those problems whenever you're subtracting a large negative number. Next up, for us to simplify these expressions, x to the power of 9 minus x to the power of 5 minus x to the power of 7 all over x cubed. Well, I can factor out an x to the power of 5 on the numerator, okay? Then we're going to have x to the power of 4, so that makes it x to the power of 9 there, because 5 plus 4 makes 9 when I expand the bracket. X to the 5 times what gives you minus x to the power of 5, that will be minus 1, and x to the power of 5 times what is minus x to the power of 7, that will be minus x squared, or x to the power of 2. And we're dividing all that by x cubed. I can now do some cancellation, so I can cancel an x cubed and then minus 3 from there, so that becomes a 2, and that obviously becomes a 1. So we are left with x squared brackets x to the power of 4 minus 1 minus x squared. Of course, if you did expand it, which is also fine, okay, you don't have to, you will also get x to the power of 6 minus x squared minus x to the power of 4, or x to the power of 4. Okay, next up, we got 12x cubed plus 8x to the power of 7 all over 4x. Again, I can factorize the numerator, so pull out a common factor of 4x cubed. In fact, I don't even have to factor out actually fully, because I can just factor out a 4x, and then I'll get what? A 3x squared plus 2x to the power of 6, and I'm dividing that by 4x. The 4x is now going to cancel, so I'm literally left with 3x squared plus 2x to the power of 6. Okay. For part C, okay, I'm going to let you guys have a go at this here, okay. But again, simplify the numerator first, factorize out if you can a 2x cubed, and then cancel down. Okay, so this is your time to practice that for part C. Okay, so next up, simplify these expressions. Part A, 3x to the power of 4y squared times 7xy cubed, or y to the 3. 3 times 7 is 21. X to the power of 4 times by x is x to the power of 5. Then I've got y squared times y cubed is y to the power of 5. Next up, okay, simplify the following expression. 25x to 12 y squared all over 5x cubed y. 25 divided by 5 is 5. X to the power of 12, and I'm dividing it by x cubed. So here the base is the same, so I'm going to subtract the powers because I'm dividing. Remember that fraction line here means a division. Okay, and then I've got y squared divided by y is just y, or y to the power of 1. Okay. Next up, we're asked to simplify the following expressions. So we got 27 r to the power of 5, s to the power of 7, all over 3 r cubed. Well, 27 divided by 3 is 9. R to the power of 5 divided by r cubed. When I'm going to subtract the powers of r, 5 take away 3 is 2. And then I'm going to tag on the s to the power of 7. Next up, we got two brackets, 4a to the 4b squared all cubed divided by 8ab squared. So let's leave the bottom, the denominator, the same. Let's write here the numerator case. I've got a bracket here, so use our index or indice rules. So we are cubing everything. So we're doing 2 lots of. So 4 cubed is 4 times 4 times 4, which is 64. Then I've got a to the power of 4 all cubed. When I've got a base raised to a power in brackets raised to another power, what do I do, guys? I multiply those powers. Okay? So a to the power of 4 all cubed is a to the power of 12. Then I've got b squared all cubed, which is b to the power of 6. Okay, I'm now going to tidy up here the numerator. 2 times 64 is 128. A to the power of 12, b to the power of 6, and we're dividing it by 8ab squared. And again, it becomes like one of the problems here that we've just done here in the previous part. Okay, so we can do 128 divided by 8. So half it, I get 64. Half it again, I get 32. Half it again, I get 16. A to the power of 12 divided by a, well, a on its own is a to the power of 1. So I'm going to subtract those powers. So it's a to the power of 11. Then I've got b to the power of 6, and I'm dividing it by b squared is b to the power of 4. 6 take away 2 is 4. Okay, next up, given that 32 is equal to 2 to the power of a, find the value of a. So this is writing 32 as a power of 2. Well, 32 we should know is 16 times 2, right? And 16 we know, okay, is 4 times 4, right? We also know that 4 is 2 times 2, so 4 is 2 times 2 then. Then the second 4 is also 2 times 2. Then I've got this final 2 on the end, times it by 2. So 32 is 2 times 2 times 2 times 2 times 2. Or I can write it as 2 to the power of 5. So A is equal to 5. So if in doubt, do prime factor decomposition if you forget. So 32, if you're wondering, can be decomposed as a product of two numbers, 2 and 16. Circle 2 here because that is a prime number. 16 decomposes into 2 and 8. Circle the 2. 8 decomposes into 2 and 4. Circle 2 here, okay. And then 4 decomposes into 2 and 2. And then I'm going to multiply all of my circle numbers. 2 times 2 times 2 times 2 times 2 is 32. Okay, or you might have already actually known actually, that's fine. But that's just to confirm here if you're, in case you're unsure. Okay, so 32 is equal to 2 to the power of 5. And this will become very important, okay, when we're solving equations involving certain base cases. So this will be very, very important to know. Okay, next up, guys, we're looking at some more indices or index rules. This part, evaluate 64 to the power of 3 over 2 or 3 halves. So I've got a fractional power. So I'm going to do the square root of 64. And then I'm going to raise it to the power of 3, or in other words, yeah, I'm going to cube it. So we root by the bottom and then power by the top. So the power of 3 halves, just to be clear, means I do the root of the number that's on the bottom of the fraction, and then I'm going to raise it to the power of the top. So the numerator is just a normal power. Okay, so I'm doing the second root or the square root of 64, and then I'm cubing it. The square root of 64 is 8, and we have 8 cubed here, which is a bit more tricky. It's 8 times 8 times 8, which if you work it out here is 512. 8 times 8 is 64, and then 64 times 8, or by 8, is 512. Okay, a little trickier for times it by 8, double it, and then double it again. Okay, but that's what obviously in my head there. Obviously, I actually already knew that actually prior to the video, so that yeah, I'm like kind of actually cheating it, but I already knew that. Okay, yeah. Okay, simplify fully. X cubed brackets 2x to the power of a third, all to the power of 6. Again, adopt our BIDMAS or our BODMAS rules. So simplify here what's inside the brackets first. So we have 2x to the power of a third, all to the power of 6. So we have 2 to the power of 6, okay, and we're multiplying that by x to the power of a third in brackets to the power of 6. So we're going to have x cubed multiplied, now 2 to the 6 here, remember 2 to the 5 is 32, so times it by 2 or double it, get 64, and I'm going to multiply that by, I've got a base raised to a power, raised to another power, guys. What do I do? Well, in this case, I'm going to multiply the powers. So a third times 6 is just 2, right? Because you have 6 thirds. Again, if you're unsure, multiplying fractions, you can think of it as 6 over 1. I'll multiply top by top, bottom by bottom. I get 6 over 3, or 6 thirds, which is equal to 2. Okay, so yeah, a third times 6 means 6 divided by 3, okay, to get that. And now I'm going to obviously tidy this up. We've got x cubed times x squared is x to the power of 5. Then we have 64 x to the power of 5 as our answer. Next up, we have to find the value of 25 to the power of minus half. So the minus does the reciprocal, so it makes base number is reciprocal, or in case of a fraction, it flips it. So the reciprocal of 25 is 1 over 25 to the power of positive half. Okay, so the numerical power obviously stays the same. So power of a half just means I do the square root. So we have 1 over the square root of 25, which is 5. So we have 1 over 5 as our answer, or 1/5, or 1 over 5. Okay, next up, simplify x in brackets 3 halves x to the power minus a quarter raised to the power of 8. So we're doing 3 halves to the power of 8. We're multiplying that by x to the power of minus a quarter, or negative a quarter, to the power of 8. And we multiply that by x at the front. So again, let's obviously tidy it up. This part here, so here I've got minus a quarter to the power of 8. Okay, so I'm going to multiply the power, so that would be minus 2. So we got x to the power of 1 plus minus 2, so it'd be x to the power of minus 1 there. And I'm multiplying it by now squaring it, 3 halves to the power of 8 means I do 3 to the power of 8 over 2 to the power of 8. Now 2 to the power of 8, yeah, I can actually work out here, because 2 to the power of 6 is 64. So 2 to the power of 7, I'm going to double that, it's 128. Double that again, I get 256. But there's no way that I'm going to do 3 to the power of 8 in my head, okay? Essentially, I'm doing 81 times 81. So if I just do it on my calculator, just give me a second, guys. Because I haven't got any light in a minute, I apologise.